Hello, welcome back to our channel. Today we are going to discuss about oscillations chapter. It is also very easy chapter and some of the formulas are matching with the waves also. So don't leave the oscillations and waves. Scope of the marks you are getting from these two chapters. Anyway, come to our point. So in this first we are starting with what is the periodic motion. The body which repeats its motion in equal intervals of time. That is called the periodic motion. Suppose Earth is revolving around the Earth. So every 24 hours it is revolving around itself. So it is repeating its motion. And every 365 days it is revolving around the sun. So that is the time period. So from this what you are understanding, the motion which repeats its motion. Even in clock also, minutes needle, seconds needle and hours needle, it is repeating its motion. That is also one of the example for periodic motion. Then we are going to discuss about the harmonic motion. See, we are expressing that periodic motion in terms of sine and cos functions. You can say that is the harmonic motion. Then what is the oscillatory motion or vibratory motion? See, the body is making the oscillations and it is going to and fro motion and it is repeating its motion in same path. That is called the oscillatory motion. But anyway, our chapter is the oscillations and we are highlighting the thing of simple harmonic motion. What is the simple harmonic motion? It must be having the periodic motion. At the same time, acceleration is directly proportional to the displacement. You can say that type of motion is called the simple harmonic motion. In simple harmonic motion, it is having the periodic motion. It is having the periodic motion. That too, acceleration is directly proportional to displacement. Here negative sign is representing both are having the opposite direction. Then we are going to discuss about what are the parameters of the simple harmonic motion. Amplitude, the maximum displacement of a particle from its mean position is called the amplitude. And already you know that pendulum, look here. It is the mean position. When it is pulled and leave it, it is making the oscillations. This is one extreme position and this is another extreme position. So initially it is traveling more distance. That maximum distance of vibrating particle is oscillating particle is called what? That is the amplitude. So beginning of this one, this is called the amplitude. But how to measure this amplitude? Amplitude we are measuring in terms of meters. Amplitude unit is the meters. Dimensional formula is L. Then we are going to discuss about the time period. The time taken for one oscillation or the time taken for one vibration is called what? Time period. What is the unit for this? You know that this is the seconds. Then frequency. What is the frequency? The number of oscillations per second or the number of vibrations per second or reciprocal of time period is called the frequency. The unit is the hertz. These are the then phase. What is phase is giving? It gives the position and direction of the particle. It gives the position and direction of the particle at any instant of time. That is called the phase. So these are the characteristics of that simple harmonic motion. Now we are going to discuss about in the case of circular motion, is it having simple harmonic or not? Already you are having one of the long answer. For this, one particle is having the circular motion. Two reference frames are there. One is the x dash, another one is the y dash. See, here you are here, otherwise one particle is here. Just you draw the normal to this one. This distance is the y and it will make an angle theta, angular displacement. So here how to find out the displacement? If you want displacement means you can go through the sine theta only. So sine theta equals to y by a. So maximum displacement is nothing but radius r equals to a. So from this y equals to a sine. Angular displacement is angular velocity into time. Instead of theta we are writing this one. So this is the displacement of this one. Okay, here what is the omega? Omega is the angular frequency. That formula is 2 pi n equals to 2 pi by t also we are writing. And we are doing one problem based on this. Look here. If y equals to a by 2 means the particle is at half of the amplitude and t equals to 1 second. Find time period. Find time period. How to find out? Instead of y we are taking a by 2 equals to a into Sine omega is the 2 pi by t. This is the 1 second. After simplification, 1 by 2. Instead of 1 by 2, sine 30 degrees. Sine 30 we are writing pi by 60 also. 180 by 60 is the 30. Then sine here 2 pi by t. Sine cancel. After that pi cancel. So t equals to how much? 120 seconds. Like that we can find out with the help of the displacement time period also. And then we are going to discuss about, when you know the displacement, next thing is the velocity. Velocity in simple harmonic motion, but general formula you know that rate of change of displacement. Rate of change of displacement is called the velocity. When you are doing the differentiation of y, d by dt of a sine omega t, what you are getting here? V equals to a omega cos omega t. A omega cos omega t. So in terms of cos function you can express like this, and you can express in terms of amplitude and displacement also. Look here, V equals to a omega. It should be right 1 minus sine square omega t. You know that cos square omega t plus sine square omega t equals to 1. If we want cos omega t means under root 1 minus sine square omega t. So we should write it V equals to omega into under root a square minus a square sine square omega t. So it should be right omega into under root a minus a square minus y square. A square minus y square. See, this is in terms of harmonic function. This is in terms of angular velocity, amplitude and displacement. But now you look here at mean position, means starting position. Displacement equals to how much? 0. At that time it is having maximum velocity, V maximum equals to a omega. Suppose in your problems find the maximum velocity means don't do such type of things. Simply we should multiply that amplitude and angular velocity. Suppose amplitude is the 5 and omega is the 10. So 10 into 5, 50 meters per second is the maximum velocity in this case. Then if at extreme position y equals to a, you are getting V minimum equals to 0. Practically where you should observe, look here. At mean position it is having the maximum velocity. At extreme position it will stop and it comes back, no. So at that time velocity equals to 0. So this is the minimum and this is the maximum. Like that we can able to find out. Not only this one, suppose if omega equals to 2 radians per second, this a equals to 4 and this a equals to 5, this y equals to 4. Then how to find out the velocity? Which formula we are using to find out this one? See, V equals to omega is the 2 under root 25 minus 16 is the 9, under root 9 is the 3. Answer is 6 meters per second. Like that we can be able to find out the displacement. This is the displacement, you must remember this. And this is the two formulas belongs to velocity, this one and this one, and V maximum also you should remember permanently a omega. Then we are focusing on what is the acceleration in this case. What is the acceleration in simple harmonic motion? So here as usual we can go through the, is represented by a. We know that a equals to rate of change of velocity. When we are doing the differentiation of velocity, what is that? A omega cos omega t. We are getting a equals to minus a. This is omega square sine omega t. It should be right minus omega square y. So instead of a and sine omega t, we are getting the displacement. Here also we are getting a maximum is how much? A maximum means y equals to a. Y equals to a. Here instead of y we are writing omega square a. Like that a minimum equals to 0. A minimum equals to 0 at mean position. So this is the acceleration and this is the maximum velocity. Suppose we are doing A maximum by V maximum. What you are getting? Minus is representing direction only when we are taking magnitude, omega square by omega 8. So this one instead of omega 2 pi by t. Then what is the time period? Look here, 2 pi into V maximum by A maximum. See, directly we can do. Suppose V maximum equals to 10. then A maximum equals to 2. How to find out the time period? 2 pi into 10 by 2, 5. So 5 2s are 10. 10 into 3.14 is the 31.4 seconds. So you have to remember what is A maximum, what is V maximum. If we are doing the A maximum by V maximum, what you are getting. All these things you have to do that. Suppose one more application. Now I think you got the clarity what is velocity, what is ax harmonic motion. See, generally what is the potential energy formula? You know that mgh in the case of kinematics, but it is in simple harmonic motion means we are getting half m omega square y square, omega square a square. See, at here also at mean position y equals to 0 means potential energy is equals to 0. Like that at extreme position y equals to a means potential energy is how much? Half m omega square a square. So this is the potential energy and this is the general formula for potential energy. Like that in SHM, what is the kinetic energy? Clearly I am saying here simple harmonic motion. Generally kinetic energy means we can say that half mv square and all these things, but here it is in SHM. You remember that what is the formula for potential energy and all this. Look here. Here kinetic energy, what we are taking, half into m into, instead of v square, omega square into a square minus y square. This is the formula. Here also at mean position displacement equals to 0, then what happens? Kinetic energy equals to half m omega square a square. See, at mean position potential energy is 0, kinetic energy is maximum means what you are understanding here at mean position, the entire energy is in terms of kinetic energy. Like that at extreme position y equals to a, you are getting Ke equals to 0. When you know the potential energy and kinetic energy, we focus on what is the total energy in simple harmonic motion. See, at mean position and at extreme position, in both the cases, total energy is half m omega square a square. So it is also following the law of conservation of energy. Energy can neither be created nor be destroyed. When we are drawing the graphs, look here, we are taking, this is the graph, we can get the graph is like this. This is at mean position and these two are the extreme positions here. Here total energy is in terms of kinetic energy, here potential energy equals to 0. Here potential energy is there, but here kinetic energy equals to 0. So this is the graph belongs to total energy in simple harmonic motion. And I want to say that in SHM, few graphs we are going to discuss. What is the displacement and time graph? Look here. This is the time and this is the displacement. You know that y equals to a sine omega t. Sine function means it can start from mu, like that. Like that, what is the velocity time graph? Look, v equals to a omega cos omega t. So it is the cos function means, see, v is on y axis, t is on x axis. We can get the cos function means like that. Like that, acceleration minus omega square a sine omega t. Once again sine function, but minus you are getting here. So this is the acceleration and this is the time. You can get this reverse of this one, like that. This is the acceleration and time graph. So these belongs to displacement, energy and potential energy, kinetic energy expressions. You must remember in discuss about for this time period of loaded spring. See, we are taking one rigid support. We are taking the spring is like that. We should attach one block of mass is how much m. So when you are applying the force and leave it, it will make to and fro motion. This displacement we are taking y. So here you can write it, force is directly proportional to minus y minus ky. Here k is called what? Force constant. K is the force constant. You know that from this ma equals to minus ky. So A equals to minus K by M into Y means A is directly proportional to minus Y means it represents the simple harmonic motion. When you are comparing and all this, omega square equals to what you are getting? K by M only. Then omega equals to under root K by M. If you want to take capital M also, you can take here. This is the capital M here also. Now, how to find out the time period and frequency? T equals to 2 pi by omega. Means it will reverse. We are getting M by K. If we consider mass of the spring, M is the mass of the spring, then you will get time period equals to 2 pi under root M plus M by 3 into K. So you remember that here K is the force constant. K is the force constant. And here also, look here, even you are placing, this is water, you are placing in the case of lift is going upwards, lift is coming downwards, there is no change in the time period. It is not affected by the acceleration due to gravity. Suppose we are taking two force constants. See, this is one wire of force constant K1 and this is another wire of force constant is K2 and this is as usual mass. In this case, resultant force constant, you should remember that K equals to K1 plus K2. Like that, if you are taking connecting parallel to this one, this is the K1 and this is the K2. Here loaded mass is the M. These two are connected in here, 1 by K equals to 1 by K1 plus 1 by K2. It should be right K equals to K1 K2 by K1 plus K2. Like that, in this case K equals to K1 plus K2. So this is about the resultant force constant. If you want to find out you can find out the time period also. Here suppose you can take it, here displacement we are taking y equals to y1 plus y2. Total displacement is this displacement plus that displacement. Here instead of y, what we are taking here, f by k. Here f by k1 plus f by k2. From this only you are getting 1 by k equals to 1 by k1 plus 1 by k2 like this. One problem also we are doing, look here. If m equals to 100 kg, then k equals to 1 Newton per meter. In this case, what is the time period and frequency? 2 pi into under root 100 by 1 means 20 pi seconds. How to find out the frequency? Reciprocal of time period, 1 by 20 pi. So this is the varying means time period also varying here. So from this you can say that time period is directly proportional to under root length and time period is inversely proportional, and we can take this is as a power. Not only this one, if the length of the pendulum is equals to radius of the earth. See, if L equals to radius of the earth, at that time period is 2 pi into under root r by 2g, you can take it. These are the formulas. Like that, one vehicle is there. Here we are taking simple pendulum. This car is moving with how much acceleration? A. Here how to find out the time period? Under root 2 pi into under root L by, here two accelerations are acting. One acceleration is acting downwards due to the earth gravity, and this is both are perpendicular to each other, means we can take it a square plus g square. Depends on the situation. Even suppose we should consider it is rotating, means we should consider mv square by r square plus mg square gravitational force, and we can find out the effective acceleration due to gravity. If the simple pendulum we are placing in water, at that time g effective equals to how much? Density, g into density of the body minus density of the liquid by density of the body. Then here time period 2 pi into, you can write it under root L by g into density of body minus density of liquid by density of the body. So all these belongs to, it's very simple chapter. Once you remember that formulas, easily you can able to deal this one. So here no difficulty, nothing. Once you learn that concept and go through the all formulas, first we will get the what is the simple harmonic motion, then we can focus what is displacement, velocity and acceleration in simple harmonic motion. Then immediately we can go through the what is the energy, potential energy and kinetic energy and total energy in simple harmonic motion. Then we can focus on the loaded spring, what is the time period. Then we can go through the series and parallel combination of that springs, and there are different cases are there, you have to follow that. Then here, then immediately we can go through the simple pendulum. Here when it depends on the acceleration due to gravity, that's why we are getting the different cases. Suppose if the length of the pendulum is equals to radius of this one, means you are getting 2 pi equals to under root r by 2g. These formulas we are getting. Not only this one, in the case of inclined plane, suppose one inclined plane here also we are using simple pendulum. Here a equals to g sin theta. If it is smooth, here t equals to 2 pi into under root l by here g sin theta we are getting. Depends on the situation, that time period of the pendulum is varying. So this is about the oscillations chapter. What is the maximum velocity means a omega. What is the maximum acceleration means what we are writing omega square a. So these basic formulas we have to remember. And here time period, one problem also we are doing. If t equals to 2 seconds means it is seconds pendulum. In some cases they are giving seconds pendulum means immediately you can take it t equals to 2 seconds. And acceleration due to gravity we are taking 9.8 meter per second square. Then find out the length of the pendulum is, you know, the t equals to 2 pi into under root l by g. So we are taking both the side square. Here 4 pi square l by g. You remember that shortcut for pi square is the approximately 10. 3.14 into 3.14 approximately you are getting the 10. See, look here, 4 into 4 equals to 40 into L by this G value also we are taking 10, easily we can do that. Here 10, here 10. So L equals to how much? 1 meter. So depends on the situation, you can deal and you can use these formulas. Thank you everyone. Please subscribe my channel.